So in the last class we seen about some data types related to this Verilog, no? So today we'll see some more data types like arrays and arrays, vectors that we'll see, and basic constructs also we'll see. Okay, basic constructs. These are the basics you need to learn before going into the programming part. Okay, so basic constructs. So I think I'm sharing the screen. My screen is visible. Okay, yeah, my screen is visible. Okay. So see here, first I will tell you the basic constructs, and next I will tell you with this remaining, I will continue with the data types. Okay, last class we completed with the netted data type. Okay, and those and so basic constructs in Verilog. What are the basic constructs in Verilog? Okay, you need to know about basic constructs in Verilog. Basic constructs in Verilog. So if you see the basic construction Verilog, so the number specification in Verilog, how we are specifying number specification in Verilog. Okay. So if you see the number specification, you have first binary. Okay, binary is nothing but it is having the base radix are 2. Okay, and next you have octal have the radix 8. Okay, and next you have decimal have the radix 10. Okay, radix or base, and hexadecimal have the radix what is the radix 16. Okay, so how you are representing this binary, decimal, binary, octal and hexadecimal, how we are representing this one. Okay, so here so basic number representation. Suppose if it is a binary, so how we are representing binary? If it is a binary, so which is having what, base 2. Okay, which is having base 2. Let us take the syntax is like this. Syntax is size tick base, and the value, size tick base and value. Okay, so size is nothing but this shows the number of bits. Okay, and base is nothing but base or radix. This is base of the number system. Suppose if it is a binary, the base is what, b. Okay, if it is octal, the base is o. If it is hexadecimal, if it is decimal, the base is d. Okay, if it is octal, the base is sorry, if it is hexadecimal, the base is h. Okay, base is h. Okay, like this, and this is nothing but value. Suppose if I want to represent like 0 0 1 1 is there. So how you are representing? So this is how many bits? 4 bit, no? 4 tick b, and this value b is the base 0 0 1 1. Like this you will represent. Okay, like this you will represent. Suppose 8 bit value is there. Suppose 4 eights are there, and 4 zeros are there. Okay, how you are representing? This is how many bits? 8 bits. Okay, this is size 8 tick binary 1 1 1 1 and 0 0 0 0. Like this you are representing. Okay, basic number representation. Suppose if it is octal value is there, octal value. Okay, suppose let us take octal value 822 is there. Okay, 822 octal is the valid octal. This is a valid octal. It's not a valid octal. Suppose any number is having the radix r, the range of the number is from 0 to r minus 1. Okay, so here if it is octal, the so radix is how much? 8. The range is what? Range is from 0 to 7 only. Here I represented 8. Okay, interior what they will do intentionally, he will ask this one as octal. Okay, if you are converting means you don't know the range. Okay, so let us take another number 722. This is valid octal. First you need to check it is a valid octal or not. Okay, this is nothing but size. So what is the size? So here octal to binary conversions you did. So each and every number, octal is having the radix 8. So this you are representing in 2 cube, no? So each and every bit you are representing is what? 3 bits. This is nothing but what? 0 1 0, and 2 is 0 1 0. Okay, so total in binary how many bits? 9, no? So you need to represent like this: 9 tick octal, 90 octal, and that's that value. What is that value? 722. 722 is my value. Okay, so this is the representation. Okay, suppose you take 55 octal is there. Okay, how we are representing? This is each number is represented in 3 bits, 101, and this is 101. 6 tick O 55, 6 tick O oct. Okay, okay, this is correct answer. Okay, suppose here if you are giving 8 tick O 55 also, the compiler will take. Why? Because if you add 2 zeros before this, the value will not change. Okay, basically for 55, what is the binary representation? 101, 101. So if you add 2 more zeros, the value will not change. Okay, so compiler will accept. Okay, so this is octal, and next hexadecimal. First we will see the decimal. Okay, so decimal having the radix of how much? 10. No? Decimal have the radix 10. Suppose if I am giving this is base 10, okay, suppose if I am giving 53 is there. Okay, 53, how we are specifying? That means 53 need to convert into binary. Okay, so binary means normally like you will do like successive division. No, I told you in the digital you need to do shortcut method. 53 means what you need to do? You need to write 1 2 4 8 16 32 164. Okay, so 53 lies between 32 64 and 32, so you need to do the subtraction. So here this is what 32 minus 1 and this is 1. So from here how many number of bits we can represent 53? 1 2 3 4 5 6. Okay, six numbers are required. Okay, no need to convert into binary, but you need to find out the minimum number of bits that you need to represent 53. So 6 bits are required. Okay, so how we are representing? 6 tick, what is the base? Decimal, and that value, that is 53. Internally it will be stored in terms of what? In terms of it will be stored in terms of binary. It will be stored in terms of binary. Okay, so that is this thing. And next, suppose if it is hexadecimal is there. Hexadecimal. If it is hexadecimal, so how it will store? So here hexadecimal. Let us take FF1. Okay, FF1 to the base 16 is there. How it will store? So hexadecimal having the radix 16. If you want to represent 2 power, this is what? 2 power 4. No, so this is what? 1111, and F is 1111, and this is 0001. Okay, so how we are representing? That means 12 tick H. H is the this is base representation, and the value FF1. FF1. Okay, suppose like if I am not specifying the size, tick octal 73, tick octal 73. So what is the size? I am not specified the size. Okay, so the default size is 32 bit. Default size is what? 32 bit. Okay, it will take as 32 bit. Okay, compiler will take as 32 bit. Tick H, let us take 55 is there. 55. So 55 means what? Here default size is, it will take as 32 bit. Okay, suppose I not mentioned any base or nothing. Suppose if I am giving 01. Okay, no, so here I not mentioned base, not mentioned any base or size. How the compiler will take? Okay, how the compiler will take? Okay, so that means the default base is decimal. Default base is what? Default base is decimal. It will take as decimal only. Okay, decimal. And default size, what is the default size? Default size is 32 bit. We are not specifying any size, so that means to avoid the confusion, compiler will understand that this is a decimal number system, and default size is what? Default size is 32 bit. Okay, default size is 32 bit. Okay, so this is about number representation, and special characters are there. Okay, so what are the special characters? You have so Verilog we support this is 4 states. Okay, Verilog will support 4 states. What are the 4 state? So most of the data types are 4 state data types. Last class I told you. So those are like 0, 1, X, Z. So that values of the data type can be either these values, that means 0 1 x z. Okay, so if you see the special characters, what are the special characters in Verilog? So special characters are x. X is nothing but what, in digital we already seen, don't care, or we can call as unknown condition, don't care or unknown condition. Okay, so this is x, either 0 or 1. Okay, and z, impedance. Okay, impedance is nothing but like, it will be like this. Okay, it not connected, okay, this we can call as high impedance. Okay, and next you have strings. Okay, strings are nothing but what? Strings, it will store strings are nothing but sequence of characters. Okay, what are strings? Strings are nothing but sequence of characters. Sequence of characters. Okay, sequence of characters. Okay, those are enclosed in double quotes. Suppose within this string I will use Gnanodaya. Okay, within the strings I will in Gnanodaya 1 2 3 4 5 6 7 8 9. Okay, total 9 are there, so it will store 9. Each character is 8 bit. Okay, 8 bits, so total 9 8 set. It will store like 9 8 sir. So based on that 9 8 sir, how much? 72. Okay, this it will store in terms of, suppose 10 characters are there, so 19 so 90 bits it will store. Okay, like that it will store. Okay, so this is nothing but strings. Okay, and next value set. I told you, value set. What is value set? Value set is so 0 means what? We can say that logical low or false condition, and 1 is nothing but logical high or true condition. Okay, and x is nothing but we can call as don't care condition, and z is nothing but high impedance. Okay, so these are nothing but the basic construction Verilog. Okay, basic construction Verilog. Okay, and next vectors we already seen. Okay, we need to see the arrays. Okay, array data type. Okay, array data type in Verilog. Okay, so what is this array data type in Verilog? We'll see. Okay, so if you see the array data type, arrays. Okay, arrays. Okay, so vectors are nothing but we can represent the one variable with multiple number of times. There we already seen that the size is declared before the vector, no? So before the variable we are representing that. Suppose we already seen vector is nothing but, suppose I am initializing reg 1:0 a. This size is declaring before the variable, that is nothing but vector. Okay, when the size is declared before the variable, that is nothing but vector. Okay, and what is array? Array is nothing but you are representing the size after the variable. You are representing the variable after the representing the size after the variable. Suppose example, if you take if you take the example of vector. Okay, reg let us take 2:0 a. 2:0 a. So how it will store? So it will store in terms of what? It will store. So I'm giving a value as a 3-tick binary 0 1 1. Okay, it will store like 0 1 1. Okay, these are the index 0 1 2. These are the index. Okay, same like array is there. So array, if it is array is there, array reg a, I am giving 2:0. Okay, 2:0. Okay, so that means how many locations you have? 3 locations. Okay, so it will store like this. 3 locations will form. Okay, like column wise it will form. So this is location 0, location 1, and location 2. Okay, so these are nothing but this is the difference between arrays and vectors. Okay, suppose if I want to give like in the arrays, I'm initializing array reg a, some 1 is to 0 is there. Okay, 1 is to 0. So I initialize two locations. In these two locations, I'm using begin initial begin, some a is 0 equal to 2 and a of 1 equal to 3. Okay, I am giving. Okay, so here what happens in 0th location, so in 0th location 2 will be stored, in 1th location 3 will be stored, 3 will be stored. Okay, so this is nothing but difference between vectors and arrays. Suppose if I take one example, suppose if you take one example, suppose module test reg a 2 is to 0. Okay, 2 is to 0, initial begin a of 0 equal to what, 5, and a of 1 equal to what, 9. Okay, and a of 2 equal to what, 3, and end module. Okay, so how it will take, so that means there is an array. How many locations are there? 3 locations are there. 0th location, first location, and second location. Okay, so 5 means what? 5 means normally it will be converted into binary 101. 9 means 1001. Okay, and 3 means what? 011. Okay, so basically reg is how many bit? 1 bit. Okay, reg will store how many bit? 1 bit. Okay, so whatever this this value is there, this value will be stored in this one, this value will be stored in this one. Okay, so this values will be stored in this. Okay, so I can try this and I can execute this in Xilinx Vivado, or I can execute in the EDA playground also. Okay, one second. Okay, EDA playground also. Okay, you can see some examples also. Suppose some programs programs related to vectors and arrays. Okay, some example programs related to vectors, and I will close this. Okay, one second. You can make use of this A model. Basically they will give some example programs. In Verilog I need to keep. Okay, vectors and array in Verilog. Okay, so here if you see, one second, in Verilog. Okay, so here I got 1D array. Okay, 1D array. So here this is one example of 1D array. That is related to Verilog. Okay, one dimensional array. Okay, Unpacked means 1D array means one dimensional array only. Okay, just here a module array example. So if I want to create a memory, I can use these vectors and arrays. Okay, so if I take some examples related to vectors, if you see, so okay, so vectors also I can use. Okay, some exams related to vectors. Okay, vectors in Verilog. Okay, Verilog. Here I'll get basic packed vector array. So packed vector array means what? This I'm initializing. So whatever the this one is there, I'm initialize before the variable. Okay, so this I can display. Suppose here if you see, yeah. So here if you see, so this one I want to display. So I can open this EDA playground. Okay, I can open this EDA playground. Okay, so here I'm opening the EDA playground. The EDA playground and is open source. Okay, EDA playground. Open this EDA playground, and you can create one account in this EDA playground. Okay, I'm opening the EDA playground. So with Google you can create your account. I created one already my account. So just I'm showing the outputs. Okay, I'm showing the outputs. So this program I am executing. So in EDA playground, you can write the program in SV as well as you can write the program in Verilog also. Okay. So here I want to write the design, that is Verilog, and next here, one second, somebody is okay. Okay, here I can write the program in where I can write program in where this is test bench. For verifying, I can write the test bench, and I can, for the design, I can write the program in this one. Okay, so that means languages you need to give as a system. This is system Verilog or Verilog, and in you need to go to the tools and you need to open. That means you need to select the FPGA board, that is Aldec Rivera. Okay, Aldec Rivera, and whatever the programs I seen, so this program is there. Just I am copying and I am seeing the output in the this EDA playground. Okay, I am seeing the output in the EDA playground. So what is this program? Just module vector basics, reg 7 down to 0 data. So that means what is the vector size? Vector size is 8-bit initial begin. Data I am using as a 8 tick binary. How many bits? 8 bits. Dollar display full vector size, that is data. So full vector I want to display. Okay, I want to display the upper nibble. What is nibble? Nibble is nothing but a group of 4 bits. Okay, so I want to display this upper nibble. So I can use this upper nibble means what? This only from 7 down to 4 I need to display. Okay, and dollar display I told you, no, this is a system task. So like in the C language you have printf, no, same like that you have dollar display. Lower nibble is nothing but 3 down to 0, 3 down to 0. So this end and end module. So just I can save this, and I can run this. Okay, see here, you will get what is the full vector value. This value, full vector value you will get. Upper nibble value means what you will get? 1101. Okay, lower nibble value means 0101. Okay, so like this you can see. Okay, so this same program I can write in Xilinx Vivado also. So just I am opening the Vivado. Okay, I am opening the Xilinx Vivado. Just I will tell you the process, how to create a project and all those things. So Xilinx Vivado I am opening. So first anything if you want to do, you need to create a project. Next project name is let us take I will take vectors. Okay, vectors, project name is vectors. Okay, or I can give data types. Okay, data types are the projects. Okay, data types. Next, okay, and next here I need to create the design. What is my design? In my program, this is vector basics is there, no, vector underscore basics is there, no. So this I will copy, and I am giving the this file name. Okay, file name, next, and finish. Project will be created. Okay, so here so that module name also I am giving same, vector basics. Okay, so this you can remove. So here source is created, vector basics source is created. This is nothing but basically this is by default you will get like company name and all those descriptions you will get. Okay, suppose comments I told you, know, comments if you write double quotes means the compiler will take as single line comment. If you want to write multiple line comments, you need to write forward slash star you need to give. Okay, forward slash star you need to give. Okay, so that is so star. So this is the multiple line comments. Okay, so this program I seen in the EDA playground. I am copying this. Just I am copying this, and I am pasting this. Okay, so pasting this, and so here if you want to write the test bench, so here if you want to add one more design, you can go to the design sources, and you can add the design sources, and you can add the create the file, and you can add the file, and whatever the test benches are there, you need to write in the simulation sources, and basically here you can add, and you can create the simulation sources. Okay, so this is the basic program for vectors I am writing. Okay, so here what I can do, so go to run simulation and behavioral simulation. Okay, so just keep in mind that whatever you are simulating, that so suppose two or more simulation or three or more simulation sources are there, you need to right click and you need to set as top module. You need to set as top module. Run simulation, run behavioral simulation. Save the file. Save the file. So it is running the simulation. So this Xilinx VVID is a large tool. It will take around 35 gigabytes of size in your C drive. Okay, this is large file. So see here, I got the output now. The full vector upper nibble. Okay, full vector is I got the value, upper nibble value, lower nibble value. Group of 4 bits is nothing but nibble. Upper nibble value, lower nibble value I got. Okay, so like this I can see the examples related to this vectors. Okay, last class I told you vectors. Suppose if I click examples related to arrays. Okay, examples, some examples related to arrays in Verilog. Arrays in Verilog. Okay, so it will give examples. Okay, so technology is increasing, you can use this technology. Okay, so you can go with this AI module, AI model, like any AI model, it will give the. So this is basic. I'm designing a memory. Range 7 down to 0 is nothing but total you have 4 locations. In these 4 locations we can accommodate how many locations. I can accommodate 8 bits of data. Okay, 8 bits of data, and here this I am copying and I am going to EDA playground. Just I am pasting this. Okay, so this is the program related to what, arrays. Okay, so here I like reg 7 down to 0, mem of 3 is to 0 is to 3. 0 is to 3 means so here I'm like I'm creating a memory. I'm creating a memory. Okay, here if you see reg, what is there, reg 7 down to 0. Okay, this is nothing but vector. Okay, mem of 0 is to 3, no, or we can call a 3 down to 0. 0 is to 3 if you see. So 0 is to 3 means what, so total you have 4 locations. Total you have how many locations? 4 locations. This is nothing but what, array. This is nothing but array. In this array, how many locations, how many values you can accommodate means each location, 0th location, first location, second location, third location. 8 bits of data we can accommodate. 8 bits of data we can accommodate. So that means by using this statement, we can develop a memory. This is how much of memory? So that means 4 cross 8. Okay, 4 cross 8 bit memory. Okay, 4 cross, so that means 4 locations are there and each of 8 bit. Okay, so this one I'm just executing one second. Yes, so in the EDA playground. Okay, so what is this program? Just I'm just 4 elements of each of how many bits, 8 bit. Initial begin, mem of 0 equal to what, 8 tick binary A1, and mem of 1 equal to 8 tick binary B2, and mem of 2 equal to 8 tick binary H. H is nothing but hexadecimal. Okay, mem of 3 equal to 8 tick H D4. Okay, so each bit is 4 bits. I'm trying to store 4 bits. Okay, display the memory content. I'm using for loop. Okay, for int I equal to 0. I can use integer also. Okay, int this is system Verilog. I can use the integer also. Integer mem of this one, mem of I, and an end module. Okay, so just I'm running this program. So I'm running this program. So when I run this, so see here, I got mem of 0 equal to A1, and mem of 1 equal to B2, and mem of 2 equal to C3. That values I am just displaying. This is nothing but what, array. Okay, this is nothing but examples of array. Okay, so examples of array like this. So same program I can see in the Xilinx VVID also. So here come out from this simulation part, and what I can do, I can add the design source, one more design source, create. So what is my program? Array 1D, no, this I am copying and I am pasting in this. Okay, finish. Module name is also same. Yes, yes. So the design will be created. Okay, the design will be created. Okay, here just this I don't want. Just I'm deleting this. I'm deleting this. Okay, that whatever the program is there, I'm copying. Just here I'm copying this. Okay, so I think program you understood, no? Any doubt in this? Okay, here it will take integer. Okay, you need to give integer in Verilog. You need to give integer. Okay, integer somewhere means sometimes this EDA playground will support, but integer is there in where integer data type is there in where Verilog. Okay, but int data type is there in system Verilog. Okay, system Verilog. Okay, you need to give with integer I. Okay, you need to give integer I somewhere. It's not taking. Okay, so this is the output like this. You can see the arrays. Okay, arrays. Okay, and next if you see you can see some examples also. Suppose a combination of arrays and vectors. Okay, some examples which include combination of arrays and vectors. Okay, vectors. This is the combination of arrays and vectors. Okay, one memory block, same thing it is giving. Okay, so like this you can check and you can try the Verilog codes. Okay, so next you have like suppose we are discussing array, no? So we are discussing array. So like module test, we are discussing arrays. Okay, so module test, let us take reg 1:0, a 1:0. Okay, so this is nothing but what this is dimension. This is dimension after the variable which decide the location, number of locations. Okay, number of location. This is nothing but what number of bits. Okay, so this is nothing but vector and this is nothing but array. Okay, so here how it will look like. So total you have two locations. Okay, so that means each of how many bit two locations are there. Each location consists of two bits. Each location consists of what? Two bits. Okay, 2 bits each. Okay, so I told you, so like reg 7 down to 0, mem of 31 down to 0. Okay, so this is nothing but what we can create a memory. Basically when the RAM design is there, we are using this only. Okay, RAM design or FIFO. Okay, FIFO design, we are using this only. Okay, how to create a memory means we can do like this. Okay, so here this is nothing but how many locations are there. So 31 down to 0 means these are 32 locations are there. In each location, what is the width of the location? 8 bit. Width of the location is 8 bit. Okay, suppose if you consider like module test, I am considering reg 7 down to 0, mem of 1 down to 0. Okay, so total how many bits are there? 8 bits are there. And how many locations are there? 2 locations are there. Okay, initial, begin. Okay, mem of 0 equal to what? 8 tick binary 1 0 0 underscore 0 double triple 1. Okay, mem of 1 equal to what? Let us take 8 tick h 12 is there. Okay, end and end module. If you want to display display the value of this mem of 0 and mem of 1, you can write. So how it will store? It will store like so here 2 locations are there. So this is 0th location and first location. So basically in the zeroth location it will store in terms of binary only. As I told you, whether you are giving hexadecimal or whether you are giving binary or octal, so at last it will store in the compiler in terms of binary only. Okay, so 12 means what? 12 hexadecimal, how you represent in binary? 4 bits. This is 001 and this is 0010. Okay, so 0001 and 0010, like this it will store. Okay, so like this it will store. Okay, so that like this you need to analyze how the means if you see the outputs, how the compiler is storing the value, that we need to understand. Okay, let us take one more example with respect to arrays. Mem of test, reg, let us take 1 down to 0, mem of 1 down to 0, initial begin. So whenever you are writing multiple lines of code, you need to write between the this initial, and initial is nothing but these are procedural assignments. In the procedural assignments we are using initial and always block. Initial is non-synthesizable, that will be not converted into hardware. Okay, initial, and if you are writing multiple lines of code, you need to write between initial and begin and end. Okay, begin and end block. Okay, so here I am writing multiple lines of code. Mem of 0 equal to what? 2 tick binary 1 0, and mem of 1 equal to what? 2 tick binary 1 1. Okay, so 1 1, and end module. Okay, so here how it will store? So that means total how many locations are there? You have 2 locations. Okay, in this 2 location, this is location 0 and location 1. This is nothing but locations, the number of locations. Array gives the number of locations. This is nothing but array. This is nothing but what? Array. Okay, and next these are nothing but what? Vector. Vector means what? Each location consists of how many values. Okay, so how many number of values it can accommodate. Okay, so that means 2 values it can accommodate. No, so that means in this mem 0, so this is mem of 0. Okay, this is mem of 1. Okay, in this what value I can accommodate? 1 0, and this is 1 1. This is 1 1. Okay, so like this. Okay, like this we can use. Okay, next if you want to see vector slicing, so vector slicing is not possible in arrays. Okay, suppose example, if you write vector slicing is available in the vectors. Okay, so in the vectors I told you, like we can access I told you with one example, 6 tick binary, that 6-bit value I can access 0th bit, I can access from 0 to 2nd bit, I can access. Suppose if you consider reg 1:0, mem of 1:0, and mem of 0 equal to 2 tick binary 0 1, mem of 1 equal to 2 tick binary 1 0. Okay, so here how it will store in the memory? It will store like this. That means this is 0th location and first location, 0 1 and 1 0. Okay, so I can't access this bit in the arrays. Okay, LSB, suppose if I want to access this LSB, okay, I want to access so that is nothing but vector slicing. So vector slicing is not possible in the arrays. Vector slicing is not possible in the arrays. Okay, this is about the basic data types. Okay, so basic data types about this we already seen about the basic data types. So basic data types are net data type. In net we have wire, var and wand, and next variable data type. In the variable data types, that is reg data type. Net data type, wire means that will not store any value. We can we can dry the value by using net data type. Whereas reg data type we can store the values, and vectors we discussed. Vector is nothing but we can initialize the size before this vector. Okay, and arrays is nothing but we can initialize the size after the vector. And arrays we discussed integer, float, all these data types, what are synthesizable and non-synthesizable constructs we discussed. Okay, In the next class, we'll see the port role connections. Okay. This is about today's session. Yes, you can practice with this EDA playground. Okay, you can practice with Xilinx Vivado also. So Xilinx Vivado, it will take more amount of size. In the Quasta Sim also, you can do the simulation, but we can't see the hardware in the Xilinx in the Quasta Sim. You can do the simulation part only. Okay. So this is about all about this today's session. Yes. So